Hello students, now today we are going to start the topic that is a logic family and the IC specification. It is a third number topic of digital electronics. Okay, so the logical family and IC specification. This is our third number topic of a digital electronics. Now what? As you know, it is a one type of the compatible, that is a compatible with means that ability to connect the output of one device to the input of another, input and output. Okay, so here in this it is compatible with a input device also and the output device also. But the main the main to connect the output of one device to the input of other. Okay students, so the compatibility, it means that the things. Now in this, where the different groups of the compatible ICs there are the different groups of the compatible IC. So now in this particular compatible IC, you have the different types of the levels, you have the different types of various supplies, you have to perform the various logical functions also, you have to use that IC in a different way. So that IC is nothing but it is a one single chip. In that single chip, the different numbers of the resistor, diode and capacitor is being inserted. And by using that particular, the IC has been built. The IC full form is nothing but it is an integrated circuit. Okay students, the integrated circuit. How this IC has been built? By using the different types of the resistor, by using the diode, by using the transistor. Okay, so these are all the different parts. Apart from this particular resistor, diode and the transistor, you have a capacitor also. Inside the IC, it is fabricated in such a way you will look that IC a single small compatible device. It will look like this. It is a small IC which consists of pins like this. Here there is a notch and here there is a dot. So like this it is been looking. These pins are opposite also, like here also the same pins are. If it is 7 pin, then here also there is a 7 pin. So you may say that it is a 14 pin IC. According to that, originally when you observe that IC, it will look like this only. Okay, now in this chapter we are going to study the different characteristics of the IC. We are going to study the different characteristics of the IC. We have the basic circuit gate. Which are the basic circuit gates? Which are the basic gates? There are three types of the basic gate. One is AND, second is OR, and third is NOT. Also, we have the derived gate. We have the derived gate, that is a NAND and the NOR. Okay, by using this particular AND or NOT, NAND and the NOR, we are going to design the circuit also. Now, in this particular, we have the tri-state device also. In this topic, we are going to study the tri-state device also, how the tri-state device is being used, where it is occurred. Here, you will give the specification also. Now, the digital circuit, in this, a very small chip, as previously I told you, it is nothing but it is a small chip, small piece of a semiconductor material. it is used. Now which is that particular material? Either the material is germanium or either the material is silicon. So when you are using this particular the material, that is a silicon or a germanium, you have the first, using the photographic technique. Photographic technique. By using this particular photographic technique, you are able to design that particular formation. Okay. By using this technique, the IC has been built out. Now, in this, it produces a surface on that particular chip. This produces surface of chip so that it may look very small. Okay, students. Now, the different components, the component used for designing IC. Which are the components? As I told you, the resistor, second capacitor, third diode, and fourth transistor. These are the main components which is very much responsible for designing the IC. Okay, it is a IC, integrated circuit. Now we have to study the different levels. As you know, certain things have a levels. In the same way, this IC is also having a specific levels. That level in your book, it is given as a level of integration. Okay. In your book, it has been given as a level of integration. Okay. Level of integration. Now, what are the different levels which we are going to consider the IC? So, the there are five different levels. Okay, there are the certain five different level, and how much gates have been used in that particular level, it has been assigned to you. Which are the first level? The first classification of that IC, the first IC classification, IC classified as, and how many number of gates which is used for the first specification, second, third, fourth, and fifth. Okay, classified, or you may say the classification. The first number classification which is used, it is nothing but it is a SSI. Okay, the second classification which is used, that is MSI. The third number classification which is used, that is third number, it is LSI. The fourth number which is used in this IC for the classification, it is VLSI. And the fifth number classification which is used in the IC, that is a ULSI, ultra large scale integration. Okay, now here I am writing the full form: small scale integration. It is medium scale integration, then it is a large scale integration, then it is a very large scale integration, it is a ultra large scale integration. So it is a full form for that particular SSI, MSI, LSI, VSI, and the USI. Now in this particular format, how the gates has been assigned? Okay, for the SSI, it requires a less than 12 number of gates. Okay, the less than 12 number of a gate is required for the SSI. Then MSI, that is a medium scale integration. The next, that is a LSI. You just keep this number in your mind and you add the different 99. Okay, here also starting from 99 it will ends, means if you add the 1 you will get the value that is 100. Okay, 100 up to when you will add the particular 9, then you will be getting 999. Okay, then VLSI, as it is 999, means in the next we have to take a 1000. Okay, this 1000 up to 9999. Okay, so these are the different gates which is used in VLSI. Also, the last, which is called in the IC classification, that is a ultra large scale integration. In that ultra large scale integration, apart from that particular 10,000 we are going to use or more, it is a different values how the gates has been assigned. You will say or more, this more than 10,000. So there are the different number of gates which is used for this particular level of the integration. Okay, now we will study the different types of the logic family, how that logic family has been classified. Within a one particular chart, you should be able to describe the different logic families. Okay, I will just draw the chart and we will discuss about that particular chart. So in this you have types of logic family. Here we write the type of logic family. This logic family has been classified into two types. First is the unipolar, second is the bipolar. First is the unipolar and second is the bipolar. This unipolar has been again classified into the three types. That is a p-channel MOSFET, then n-channel MOSFET, and then last it is a CMOS. C means it is a complementary MOSFET. It is all written in the capital letter. Okay. So the unipolar has been classified into three types, that is a p channel, n channel, and the complementary metal oxide semiconductor field effect transistor. This bipolar, has been classified into the two types. First is the saturated, and second is the non-saturated. Okay students, this saturated is again classified into a different six types. 1, 2, 3, 4, 5 and 6. So these are the six types. First is the RTL, second is the DCTL, the third is the T square L, then fourth is the DTL, then fifth is the HTL, and sixth is the TTL. Okay, so these are the six types which has been classified according to the saturated in the bipolar. Now in the non-saturated, it has been classified into the two types. Non-saturated has been classified into two types, that is a Schottky TTL, and second is the ECL, that is a emitter coupled logic. Okay, so here in this particular chart, it is very much easy for you to understand how the logical family has been classified. Okay, once again, the logical family has been classified into two types, that is a unipolar and second is the bipolar. The unipolar is classified into the three types, that is a this PCH is nothing but P channel. P channel, it is a MOSFET. Also it is a N channel, N channel MOSFET, and it is a complementary metal oxide semiconductor field effect transistor. I will write down metal oxide semiconductor field effect transistor. So it is a full form for the metal MOSFET, MOSFET. Okay, students. So you may understand from this, there is a P-channel metal oxide semiconductor field effect transistor. Here it is a N-channel metal oxide field effect transistor. Here it is a complementary metal oxide semiconductor field effect transistor. Okay. Now let's come to the bipolar. Bipolar has been classified into the two types. First is the saturated and second is the non-saturated. The saturated has been classified into six different types. First is the RTL, that is a resistor, transistor, logic. Second is the direct coupled transistor logic. Okay, it is a full form. It is a full form for that particular direct coupled transistor logic. Then a T square L transistor logic. Then DTL diode transistor logic. Then a high threshold logic. Then transistor logic. So it is having the different full forms like this. Then the non-saturated has been classified into the two types, that is the Schottky TTL and the ECL, that is the emitter coupled logic. Okay, so it is a classification. In your examination also, if it is asked, the question is explain the classification of a logic family. This is the chart. From this chart, you may elaborate the whole things. Okay.